Bismillahirrahmanirrahim. Welcome to the Electrical Engineering channel. In this lecture, I am going to demonstrate the auto transformer. So, auto transformer is a single winding transformer, and in this case, primary and secondary windings are not isolated from each other electrically. So, in auto transformer, the voltage transformation ratio is equal to the turn ratio, as is the case with a two winding transformer. So, V2 over V1 is equal to N2 over N1, and it is equal to I1 over I2, and this is equal to A. So the step down configuration of auto transformer is shown in this figure. We have more number of turns for the primary side, and we have less number of turns at the secondary side. So secondary side is made by incorporating a tapping in at the center of the single winding. So this is a single winding transformer. If we use this configuration, it will behave as a step down transformer. If we consider, or if we invert, or if we electrically mirror this configuration, we will get this circuit, and it will behave as a voltage step up auto transformer. So this is the primary voltage. Here current I1 is flowing through the primary, and the current which is leaving from this side is the secondary current, and this is the current I node. So I node will be added in I1 to become I2. So in this case, V1 will be greater than V2, but I2 will be greater than I1. So I2 is the combination of I1 and I node. And in this case, these are the directions of the current. So in this case, V1 is smaller than V2, but this is I1 which is divided into I2 and I node. So this is I2 and this is I node. So again, this is a voltage step down but current step up transformer, and this is a voltage step up and current step down transformer. So the main purpose of using this auto transformer is the copper saving. Since we have only single turn, we can save substantial amount of copper while designing a transformer. The only problem with an auto transformer is that it doesn't provide us the isolation purpose. So isolation cannot be achieved with the auto transformer. If we want to achieve electrical isolation between two systems, we have to use a two winding transformer, because primary and secondary windings are electrically isolated from each other. In that case, here we have single winding, so they are not electrically isolated from each other. So in order to calculate the saving of copper in auto transformer, we have to do this brief mathematics. So weight of copper in any winding is actually proportional to the number of turns times the current. So Ni is actually the quantity at which the weight of copper depends. So weight of copper in this branch AC is actually proportional to N1 minus N2 times I1, because the primary current is I1, and from this in this branch A to C, the number of turns are equal to N1 minus N2. So total number of primary turns are N1, number of secondary turns are N2. So number of turns in AC will be equal to N1 minus N2, and the current flowing through this AC branch is actually I1. Now we will consider this branch, and in this branch, number of turns are equal to N2, and the current is actually, in this case, is I naught. And from this expression, I naught is equal to I2 minus I1. So current is I2 minus I1, and number of turns are equal to N2. So we will add these two branches. So if we add this branch and this branch, we will actually have considered the whole primary winding. So total weight is proportional to N1 minus N2 times I1 plus N2 times I2 minus I1. And for a two winding transformer, weight of copper in primary is proportional to N1 I1, and weight of copper in secondary is proportional to N2 I2. So total weight will be proportional to N1 I1 plus N2 I2, and weight of copper in auto transformer divided by weight of copper in a two winding transformer is equal to this term divided by this term. So we have to uh, open these expressions. So they will become N1 I1 minus N2 I1 plus N2 I2 minus N2 I1 divided by N1 I1 plus N2 I2. So N1 I1 plus N2 I2 will be divided with N1 I1 plus N2 I2, and this minus N2 I1 and minus N2 I1, it will become minus 2 N2 I1. So N1 I1 plus N2 I2 will be divided with this N1 I1 plus N2 I2, and it will become 1, and it will become minus 2 N2 I1 divided by N1 I1 plus N2 I2. So we can divide the denominator and the numerator with N1 I1. So it will become 2 N2 I1 divided by N1 I1. So it will become 2 N2 over N1, and it will become N1 I1 divided by N1 I1 will become 1, and N2 I2 divided by N1 I1, and it will become N2 over N1 into I2 over I1, and I2 over I1 is equal to N1 over N2 from this expression. So it will become I2 over I1 will be equal to N1 over N2. So they will be cancelled out, and we will get 1 plus 1. So 1 plus 1 will become 2, and it will be cancelled out with this 2. And N2 over N1 is actually equal to A. So by mistake, I have written 1 over A over here, but N2 over N1 is equal to A. So N2 over N1 is equal to A, and it will become 1 minus 1 minus A. So this is the weight of copper in auto transformer divided by weight of copper in a two winding transformer equal to 1 over A. So WAT will be equal to 1 minus A WT. So A is definitely smaller than 1, and 1 minus A will also be less than 1. So it means WAT will always be smaller than WTA. So weight of copper in a two transformer is always smaller than weight of copper in a two winding transformer. So this WAT is equal to 1 minus A times WT. So by mistake, I have written K over here. Actually, it is A. So as this A approaches unity, saving will increase. So when this A is high and it is close to unity, this weight of copper in auto transformer will be further reduced. If this A is small, then if A is zero, then weight of copper in auto transformer will be equal to the weight of copper in a two winding transformer. So now we can convert a two winding transformer to an auto transformer. So this is a two winding transformer, and we can do the connection keeping in mind either the additive polarity can be achieved or a subtractive polarity can be achieved. So these are the dot conventions. If we want to achieve the additive polarity, then this here we have dot, and where we have non-dot side, and this dot side should be connected to this non-dot side, and this non-dot side will come at the bottom. So if we do such a connection, then we will get the additive polarity of the transformers. Uh, so this is 2400 volts, and here we have 240 volts, and we have to connect this side with this side in such a way. So this is the first terminal, this is the second terminal, and at the end we will have the primary terminals are the same, and we will have such equivalent circuit. So these dot sides are here, and we will get 2640 volts. So similarly, if we want to achieve the subtractive polarity, then this dot side should come at the bottom, and then such a connection will be achieved. So this is the first terminal, this is the input side, and this will come at the bottom, and these two sides will be connected with each other. So here we will get such a combination. So this is the dot side of the primary side, primary winding, and this dot side of the secondary side will come at the bottom, and here we will have the subtractive polarity. So if we have positive over here, we will have positive over here. So the resultant EMFs at these two windings will be subtracted from each other. So if 2400 volts are here, 240 volts are here, and it will be subtracted from this, and we will get 2160 volts. So that is all about our today's lecture on auto transformers. I hope you have enjoyed and understood the concepts. So for watching more similar videos, please stay tuned to this YouTube channel. Until the next lecture, it's goodbye.